Welcome, bienvenidos al Instituto Cervantes. I am Victor Ugarte, the director of the Instituto Cervantes in London. Welcome also to our online audience, which is today bigger than the one here, but anyway, welcome everybody. Today we introduce you the book The Reinvention of Science, Slaying the Dragons of Dogma and Ignorance. We have here two of the three authors, Bernard Jones and Vicent Martínez. Thank you very much for being here. And of course, today's chair, that will be Sonia Antoranz Contera. Also, thank you very much for being here as a chair. Covering a broad timeline from ancient civilizations to modern discoveries, the book explores how controversy, suppression, and resistance to change have shaped scientific progress. While focusing mainly on astronomy, cosmology, and physics, it also touches on geology, biology, paleontology, and artificial intelligence, highlighting how our understanding of nature has gone through the rejection of fallacies and the pursuit of evidence based on knowledge. Throughout history, science has often relied on invisible or hypothetical entities, but science is essential for human development. It improves our lives and helps us understand the world. While today's truths may be revised by future discoveries, that's the strength of science. It evolves. It's based on evidence and constant testing, making it the closest thing we have to truth. Science doesn't claim certainty; it seeks through facts, and that's why it drives real progress. Let me introduce you to Sonia, to our chair, because she will introduce the speakers today. Sonia Antoranz Contera she's full professor of biological physics at the University of Oxford and has been involved in various prestigious roles, including co-director professor of biological physics at Oxford University. She's a distinguished physicist and a member of the CERU-SRUK, Society of Spanish Researchers in the United Kingdom. And just to mention some events we have in the next days, we have a symposium called Spain 50 Years from Dictatorship to Democracy. It's in September the 20th when Franco died 50 years ago. So we have a series of talks with Hispanists, among them Silport Preston, that will be, this is sold out in the Garden Cinema with the film. We have Professor Nuria Capdevila and many others. And we have on Monday, the 10th of November, at the Spanish Embassy, William Chislett in conversation with Michael Portillo, talking about Mr. Chislett's book, The Impertinent Curious Ones, British Hispanophiles from the 19th century to the 21st century. And many other things, so please join watch our website and check it there, because we have 7 events related to this 50th anniversary. Thank you very much, and I give the floor to our chair today. Thank you. Gracias.
Thank you to Instituto Cervantes for hosting this event and inviting me to come and host our wonderful speakers tonight. As he said, we have 2 of the writers of the book that I hope you get when you get out of here, The Reinvention of Science. I think they are on sale upstairs. And I give a couple of sentences about their lives, and we plan that they will give us a brief talk about the book, some of the topics of the book. You can cover all these pages in 20 minutes, and then we'll have a brief discussion. And then, of course, we will open the floor for further questions from the audience. So Professor Bernard Jones is an emeritus professor at the Captain Astronomical Institute at the University of Groningen in the Netherlands. And his research covered many areas of astrophysics, both theoretical and observational, with an emphasis in cosmology, where he is published and widely published and cited. He's written several books, including this one. And he did his PhD in Cambridge with 2 very famous scientists, Dennis Yaman that, of course, was important in Oxford for many years, supervisor of many of my colleagues, and Lord Martin Rees. And then he supervised a lot of students, including the other author of the book, which is Vicent Martínez, who was a postdoc and a PhD student of Bernard. And he's a professor of astronomy and astrophysics of the University of Valencia in Spain, and was the director of the Astronomical Observatory for 11 years. He's also an astrophysicist and focused on larger scale structure of the universe. And he is very committed to scientific talking, scientific writing, and the public dissemination of science. And he's got many awards for that. So I think we have now the talk about the book. So please join me welcoming our speaker.
Okay, thank you for coming. This is an exercise in which I discover what's in our book. So the reinvention of science is about how science has worked in the past and how it works now and how we hope it may be able to work in the future of AI and such. And we've got a lot of case studies to show how that science has evolved. We have a little promotional movie, but it's he's a movie director now.
What do the luminiferous ether, phlogiston, crystalline spheres, and the homunculus have in common? None of them ever actually existed, but belief in their reality held up progress, like dragons on the edges of a map, discouraging exploration.
The Reinvention of Science. Slaying the Dragons of Dogma and Ignorance contains an extensive history of how science evolved through controversy, suppression, and the wish to maintain the status quo.
How did the authors know each other? Student Bernard Jones first encountered postdoc Virginia Trimble in the early 70s at the Institute of Theoretical Astronomy in Cambridge. At this time, co-author Vicent Martínez was at the primary school. Student Vicent Martínez then encountered Professor Jones, who became his advisor in 1986 at Nordita and the Niels Bohr Institute in Copenhagen.
And Professor Trimble encountered Dr. Martínez as his junior co-organizer of a September 2000 summer school on historical development of modern cosmology in Valencia. Our story passes from the Babylonians and Greeks through the Middle Ages, the Renaissance and the scientific revolution to current events. The authors discuss the evolution of our knowledge, the controversy about the extinction of dinosaurs, and open questions in contemporary science such as dark matter, dark energy, black holes, and the origin of the universe, including how we understand the subatomic world of elementary particles. What happens when three astronomers at the forefront of their field pause to look back at the origins of all they know? The result, the reinvention of science, calls to mind the Voyager spacecraft's photo of the Earth as a pale blue dot taken at a distance of nearly 4 billion miles from the Sun. Here in these pages, the authors lead the reader through the ideas that have brought us from mythology to the brink of dark matter. Dava Sobel.
Dogma. And this is what it's about. The chief idea is that we have to overcome it. And people, some, were burned at the stake for their ideas, which were correct. That didn't matter, apparently. And some triumphed and went on to win Nobel Prizes. So it's a great spectrum. Overcoming dogma has been different, of course, because dogma is punished, scientists punished in different ages by different processes. It was rather cruel. In the year that Shakespeare was writing Hamlet, they burned a man at the stake. Just for his beliefs. It's incredible. Okay, can move on. Oh yes, our missing number 3, Virginia Trimble was a genius IQ 180 scientist when she was a young lady, and she still had to struggle to become a leading scientist. And she's won many, many awards for the articles she's written and things. And we're very honored to have been able to work with her. I've known her since about 1969, thereabouts. And that's when she came to Cambridge and started doing a postdoctoral position in science. Unfortunately, she can't be with us at the moment, and she's not very well. And we're the oldies, and this is the next generation as oldies. So you'll go. We're wearing hearing aids as well.
Okay.
So,
Okay. Now I continue, and in a book, you always has to find a way to put a very small thing in the back cover, a part of the blurs of important people like Martin Rees or whatever. But this is what is said there. What the luminiferous ether, phlogiston, the homunculus, and the crystalline spheres have in common. None of them ever actually existed, but belief in reality held up progress, like, with this metaphor, dragons on the edge of a map discouraging exploration. And there is a couple of statements in a poem by the neoclassics English poet Alexander Pope, which really summarize what we try to do in the book. And in fact, was the first thing that Virginia and myself discovered more or less simultaneously. And this one, be not the first by whom the new are tried, nor yet the last to leave the old aside. Okay, now we are going to go very quick through the different parts of the book. The first part, it's called playing with this dragon idea. It's breaking the dragon's egg, how science is born. And this part has 4 chapters. And in the first chapter, we talk about the origin of science with this title, Ether and Atoms. We talk about, for instance, the difference between the myths and the science, and all the civilizations, the ancient civilizations have myths to explain how to life can be on Earth. And typically, they try to separate the Earth of the heavens. For instance, for the Egyptians, is the god Shu, who is the air, holds Nut, the starry sky, apart from her brother, Greb, who is the earth, and making room on the surface of the earth to have life there. And this it happens the same for the Babylonians, for the Chinese. The only difference is where to put each part. I mean, in the Judeo-Christian things, God did it just advance everything correctly. It's different, but also it separates things. It separates the water from the earth, the heavens from the earth, etc. Then when science starts, in our opinion, is in the Hellenistic period. But to understand the Hellenistic period, we have even to go to the classic Greece. And then this is a good example of having already different streams of knowledge and always one preserving. And then, we are all the descendants of Aristotle and not the descendants of the atomists. And probably this is a pity, but this is how history went. I mean, if Aristotle wanted a finite universe. In the Kaelos he published, nobody can be infinite. Everybody has boundaries, and what is bounded is finite. And this was in contrast, for instance, with other people like the atomists, Democritus of Abeda, Epicurus, but all of them were popularized by Lucretius. The problem with Lucretius is that he wrote a fantastic poem, a text called the Rerum Natura, in which he advocates for a different kind of life, more hedonistic if you want. But scientifically, he claims for an infinite universe, for an infinity of inhabited worlds. The world will have a finite age. This is roughly similar to what we believe today. But this poem was lost for centuries. And one of the chapters is about this last poem. It was written by Bernard, and you continues.
Yes, I mean, the book, of course, The Swerve, was a first order bestseller in the New York Times list. And so having an opinion which is slightly different about how things worked was quite an interesting thing to write about. So, anyway, so the hero of this is a guy called Poggio. He's a member of the church. And he's the one who is delegated to go round and find the manuscript. We're talking about the middle of the 15th century. It had been lost for 1500 years almost. And this guy found it in a monastery in Germany. It was a time of three popes, one time, really quite interesting from that point of view. And he found it. It then got lost again. And eventually it wound up in the eyes, hello, the next one. Of the lady you see on the right. Now, she's a very interesting lady because she is a Puritan and she lives in the 17th century, the beginning of the 17th century. Her husband is not a soldier. He's one of the chief grand dragons of the Civil War on the side of the anti-royalists. So she's a very conservative woman, and she translated this book, including the poetic rhythm, into the English language. This was the first translation ever, and she was shocked by what she read. It was absolutely against everything she believed in her life as a Puritan. She wanted to destroy it. She couldn't bring herself to do so, so she gave the only copy to the Duke of Anglesey. I think that several of her copies were stolen and taken away by other people because it survived. But it's the first time we really understood what Lucretius was talking about. It's a tremendously popular book in Paris in the early times. Now we come to the time, this is even before everything that we know about modern cosmology. Well, a man at Oxford, not Cambridge, Oxford, very sad, basically digs. He was the first person to say and dare to say that the universe was infinite. So from the normal crystalline sphere with everything happening inside it and everything, we then have to believe that outside the stars which are fixed, basically are infinite. Tremendous concept. And today, that is still, I think, a concept that we don't deal with and almost refuse to deal with. We just simply believe it. I shouldn't say that.
Okay, yeah. Then this diagram is the diagram of Copernicus, published about 40 years later, of the real diagram in Copernicus' book, in which we start the next part of the book about talking about crystalline spheres, which are one of these invoking elements that you need to maintain the consistency of your idea of the cosmos. And also these crystalline spheres in the geocentric models were needed with epicycles, difference, and other constructions that are just put on the moment that you want to explain how the universe works, how the retrograde motion of the planets is functioning. These crystalline spheres are also in the model that Copernicus present in the Revolutionibus. As you can see here, the fixed stars is just a single spheres, indifferent of the Thomas Digges book, which appears a bit later, but where the last sphere is expanding infinitely in altitude, as it was read in Old English there. Okay, but things start to change because also the observations come with new things, and there are people who is able to understand these new things. And there was the fortune that in November 11, 1572, it appears a new star in the sky, close to the constellation of Cassiopeia. Today we know that it was a supernova. But for instance, here you have an engraving from the 19th century, but trying to resemble the moment in which the Danish astronomer Tycho Brahe is observing this supernova in the constellation of Cassiopeia. It was a new star. He wrote a book, but it was not the only one. For instance, Thomas Digges wrote also a lot of things, an Englishman, about the supernova. And in Spain, the astronomer Jerónimo Muñoz wrote a book commissioned by the King Philip II. Okay, we published a few years ago this diagram. It's just trying to recreate people who knows Valencia could recognize this civil Gothic beautiful building, which is La Lonja. And then we imagine that because Jerónimo Muñoz in that time was living in Valencia, he was a full professor in the University of Valencia, but the University of Salamanca offered him to pay 10 times his salary, and obviously he left. I mean, I don't know if this is possible now in Spain or in England, but salaries were the way of moving people at that time. But the observation of the supernova was done from Valencia. And the supernova implies a completely change in the idea of the Aristotelian, because for the Aristotle, the heavenly sky was pure, immutable, no changes can be done, and appearing a new star was something that it was not acceptable for any Aristotelian peoples. In fact, Jerónimo Muñoz calls his book, knowing that probably it's not a comet, but he calls the book, he entitled his book, The Book of the New Comet, not the new star, okay? And a few years later, a big comet appears in Europe. Here you have an engraving that it's in Prague, and it's something very huge. And Tycho Brahe again studied this comet, and with his system of the world, which is different of the Copernican and the geocentrical, he recognized that the crystalline spheres that has been there for centuries, made by this element that Aristotle called quintessence, a fifth element, a part of the air, fire, water, and well, what I am missing one. But this quintessence was the thing which made the heavens and the bodies, but also the crystalline spheres. And Tycho Brahe demonstrates that certainly these crystalline spheres has not to be there, because the comet needs to cross them, and if they are solid, this cannot be done. Okay, we finish this part just talking about dark things that are postulated. And we talk today, and we will see in a minute, about dark matter, dark energy in cosmology. For sure, you have listened in these concepts. But dark objects appear very early in the history of science. For instance, here, the Englishman, John Goodricke, who was member of the Royal Society with 21 years old, because he was the discovery of the stars with a change with time, its brightness, in particular what we call variable stars or Cepheid stars. But the first star he found was this demon star, Algol, who is a star that changed its brightness because a dark companion passes between the star and our position. And just looking how changed the brightness of the sky, John Goodricke postulated the existence of a dark companion, and it was one of these dark objects that we will be talking later. But at this moment, we make another part of the book going to a very exciting aspect of science today, more related with paleontology, which is how the dinosaurs disappears.
Yes, the idea of introducing geology as a part of the cosmology of the world we live in was actually encouraged by Janet Jones, my wife. I always do as I'm told, so we went ahead and did it. It is actually a change in dogma going on now, and that's why it's a very real one, and this is a very, very important example. when a meteorite was said to have hit the Earth and wiped out all the dinosaurs, which is probably what you've all heard, there was no alternative either considered or tolerated. It was an example of a takeover bid by a group of individuals who, well, you meet them in the book. This is a no punches pulled type of story. We have on the left a young girl called Mary Anning, and depicted a discovery, an ichthyosaur, if you can spell it, in the shores of southern England. She digs it up. She starts as whole, and that's her at an older age. She's uneducated and she can't read. She can count money. That's about it. But she digs up this thing and draws diagrams of it, which are highly detailed, showing that she's not actually stupid. And this goes round the world, but she gets no credit for it. She wasn't recognized for another 30 years as being anybody who ever contributed to it. Everybody who wrote about it stole her work and didn't give it to her. On the right, we have Marie Tarp, who not a long time ago, certainly within my lifetime, discovered the fact that the ocean was splitting apart. The Atlantic, the two, America and England, were happily moving apart. Europe was no longer, America was no longer a part of England. And so we needed to find some scientific basis for this new revolution. And this was produced in 1918 by Wegener, who showed us that the Earth has been changing, and that's what started killing the dinosaurs, is the alternative to the meteorite hitting everything that goes on. The meteorite story was started by a father and son. The father had actually won the Nobel Prize for nuclear physics. If they hadn't done that, he'd have won it for one of the many other things he did, but he was not a nice character. And he was bombastic, abusive, bullying. And when the next lady who comes along, Gerta Keller, went to a conference where he was, she was basically totally abused for saying that there was no proof within the work they had done that this meteorite killed those dinosaurs. So we tell the entire story is revealed. We should have a headline on a newspaper saying, you know, they were killed by the drifting of the continents. Here's Gerta Keller. These are fictions from her young book, a plug for her book. It's really an autobiography. This is where she found the proofs, and this is her with her team. And this was at the time that she was working of the Zaparista uprising in Mexico. She actually got shot through a lung at one point and various other things. But, you know, scientists do that kind of crazy thing. So that's Gerta Keller. Where are we? Yes. She worked in India, in the blue part, which is a volcano. That's not one volcano. That is a few 100,000 Krakatoas all going off at the same time. So if you think volcanoes can contribute to climate change, you should imagine in your mind 100,000. She studies these little things, which are single-celled animals, which are the animals, believe it or not, the plants, and they're divided into cells. And by looking at the death of that, she can tell us exactly when the extinction took place. And she finds that the meteorite hit 250,000 years before the extinction of these beasties. So the meteorite didn't, in her opinion, destroy the dinosaurs. This is an example of what she studied. And this is the Deccan traps in India. I don't know how geologists understand this stuff. It's a kind of a miracle, but they do their thing and I do my thing, and they probably don't understand the equations I write. So off you go.
Okay, we move to part 4 of the book, where we try to go to other fields different of geology and astronomy. And the first chapter is the non-invented here syndrome, because this, for instance, could be applied to Alfred Wegener. I mean, he was not of the field of geology, and probably this was the reason that many of the geologists didn't take care about the continental drift theory, which is quite right. And for many years, in particular, American geologists, there is a whole book by Naomi Orozco explaining how they didn't believe this continental drift theory by Alfred Wegener, because he was on the business. And also, we wanted also to mention other aspects, for instance, in physiology, when the first microscopes came into circulation, people wanted to look at a single cell. And the easiest single cell that one can probably reach, and as Alice Roberts say, it is the details I leave to your imagination, is the sperm. Okay, and looking at the sperm, people, in particular in the Netherlands, found that within the sperm there was a complete manichae of a person, and they even wrote it in books and just make this kind of diagrams, because the preformist ideas that they have, they didn't want to have any responsibility in the heredity process in the woman. Okay, and everything, just the woman put the nutrients if you want, but the rest was just everything was done by the men. And obviously this was seen with the new instrument, because you wanted to see it, just because that, I mean, then this is a preconception that in science happens many times. Okay, and there is also a part about politics, the world wars, and people like Henry Moseley, who could not get the Nobel Prize because he just died in the First World War, or people who also didn't got the Nobel Prize, and his supervisors got it for the discovery of the pulsars, like Jocelyn Bell Barnett. Okay, she did the work when she was a student in Cambridge, when she was doing the PhD. It was not really the topic, but it was something that she found by chance. But she published the results. At the end, the Nobel Prize went to her supervisor, and Martin Ryle as well. We talk in this part of the book about many other aspects of modern astronomy, like black holes, and now Bernard, black holes and gravitational waves.
Yes, I mean, Virginia's husband is depicted in the picture on the right, Joe Weber. Joe was basically the first man to look for gravitational waves. Gravitational waves, what are they? It's complicated. It's described. He looked at the shaking of a bar by something which was a small fraction of the diameter of an electron. The fact that he thought he could do this was amazing. He could, but he never discovered the waves. They were discovered later in the LIGO experiments. On the left, we have another proof of general relativity, which is one of the greatest experiments of this century, which is the Event Horizon Telescope's image of a black hole surrounded by a disk going around it. This was a phenomenal discovery, and I hope one day that team, who are still continuing their work, get a Nobel Prize. They will thoroughly deserve it. It's about half a dozen telescopes all around the world putting all their information together. International collaboration, which is what science is about, in my opinion.
Without pretending, we are just finishing the book. We have just going to the last part. We mention a lot of women in science, and that was not originally thought, but it happens that at the end they play a crucial role in the history that we wanted to tell right in the book. And for instance, for measuring the universe, the work done by the Harvard astronomers, beautifully explained by Dava Sobel in this book, The Glass Universe. We are in a place where books are loved, and we like to talk about ours, but we have put many of other books that we enjoyed, like the Swerve or this book, The Glass Universe by Dava Sobel, where she explains the work, but all these women in the Harvard Observatory at the end of the 18th century, at the beginning of the 19th century, at the beginning of the 20th century. Particular, for instance, the work by Henrietta Leavitt, who provides a tool to measure the distances in the universe, just looking precisely to a relationship between these variable stars and to know how to measure the distance properly to these variable stars. By the way, at this moment, things like dark objects are still postulated, and sometimes they are founded. For instance, when it's discovered by another born in Germany but Englishman, William Herschel, the planet Uranus. People start to study Uranus continuously because it was a new planet for the first time. I mean, the old planets were already known because they are seen by the naked eye from the Greeks to now. But when Uranus appears in the telescope in Bath, where William Herschel and his sister Caroline Herschel were working, all the people tried to study it, and because Newton laws were applied to understand the movements of the planets, people realized that Uranus has a very strange behavior. And the behavior was, this strangeness, this weird behavior was due to the fact that it was another planet in a different orbit, and that was Neptune. And Neptune was discovered because several astronomers in France and England pointed out where it has to be, and the German astronomer found it exactly when they were saying. And in the same way, it was something strange in the movement of Mercury, something that technically it's called the perihelion of Mercury, the shift of the perihelion. And the shift didn't fit well the Newtonian laws, okay? And what did people did at that moment? Exactly the same. They postulate the existence of a new Neptune, but in this case, intramercurial planet, and it was Vulcan. And Vulcan was a planet that it was even in the books, in the books of the school at the end of the 19th century, and many theories were postulated to explain this anomaly in Mercury, and the main one was the existence of this dark object. Again, we postulate a dark entity. This is something that along the book is always there. But this postulated dragon were slided for those who accepted Einstein's general theory. In this case, Vulcan didn't exist. And then we have to shift the theoretical paradigm to explain this observation, to explain the shift in the perihelion of Mercury. Today, we have dark matter, dark energy. For instance, you have here one diagram and some of the illustrations, the diagram done by Javier Pérez Belmonte with our ideas. And along the talk, we have been showing many of the cartoons of the different scientists made by Isabel Galvez. Here you have Vera Rubin, who was one of the first person proposing the existence of dark matter in the context of to explain the velocities of the stars around the center of the spiral galaxies. And well, this was something that still we have to deal with. We do not know what dark matter is. We do not know what dark energy is. But these dragons are there waiting for the proof or waiting for this proof. They could be Neptunes or they could be Vulcans. Okay? Now we are finishing. We go just to the last part with cosmology again.
Yes, the expansion of the universe was a revolution and a shock. Nobody ever imagined that anything could be expanding into nothing. Discovered by Hubble using data that he did not acquire, and discovering something that he never believed because he always believed the universe was non-expanding, so that we still call it the Hubble expansion. He never believed it. And this is the proof where things going a long way are expanding faster. We now know a lot more about it, and we basically are the discovery of the microwave background in 1965 saw the death of the steady state theory. Very sad. I was a great fan, but everybody immediately moved over to the Big Bang theory because that had been predicted by George Gamow. Dark matter, 80% of the universe is dominated by stuff we have no idea about, don't see, which means that if I lived long enough, my job as an astronomer, cosmologist, would be guaranteed because there's things to discover. What's next? Yeah. Last chapter about Ada Lovelace. We have to mention her because this is the next revolution in science, incredibly important. She's not the inventor of AI. She's really the first person to write computer programs, daughter of the poet Byron. I like Byron's poetry. Her first paper, and only paper, is fantastic. AI has led to useful predictions. The alpha model, Google alpha model, is basically discovery of proteins. So we are getting somewhere, but we're having a social revolution now because of AI, and I think that's worth a future discussion. The book finishes with a point of philosophy, which is actually written in this paragraph by my wife Janet. It actually questions everything we say on the grounds of the theory of knowledge. Philosophy dominates. And we can read. My glasses are the wrong glasses. Okay. Ultimately, mathematical equations are always just models of what we think is the real world. See, as a mathematician, that's me gone. Reality hides behind the shield of our senses. Deep stuff. By the same token, other calculating tools, such as an AI program and advanced instrumentation, are just providing models. Reality always remains elusively beyond the edge of certainty, or science is always open to reinvention. It's a lovely sentence or paragraph. I should remember it by heart next time that I don't have to read it with the wrong glasses.
Okay, thank you.
Thank you very much.
So thank you very much for the lovely presentation with all the very different topics that you've been covering in the books. And I've been asked to give you some questions. As I read the book and I was hearing you today, I had a kind of sort of, if you allow me, a psychoanalytical question. Okay, you both, especially when I read your biographies, are very much thriving in mainstream science. You went to Cambridge, you're supervisors, you work with Nobel Prizes, you're establishment figures. You never questioned the dogmas, or maybe you did, that's what I want to ask you, that the book is about. Why did you write it?
Well, I think I started, then you can continue. I mean, at the beginning and the preface, we say that the book started with my connection with Virginia, who always has these ideas. He obviously sees it in the stream science as well, but we wanted just to show that through history, we need to postulate things that we really do not know if they are real or not. And for instance, we live in, I talk with, and you can do it as well in your work, if I talk with a biologist and I say, well, I dedicate to a field where 95% of the content of the field is unknown. And the other guys say me, what are you doing that? I mean, you are losing time. I mean, I look for neurons, or I look for.
Well, I would argue that biology is also in even worse
But
state.
anyway, the idea of postulating things that you believe in them strongly is something that was a bit repulsive to us. And in order to have a more broad view, I mean, those ideas are there, but they need to be proved. Otherwise, they have to be forgotten. Okay, this is my. You can.
Yeah, no, I can add to that as a physicist that works in biology, I can see the usefulness of physics because we're able to change the ontological framework. We got used to change and to not admit everything as truth, where biology is dogma from beginning to the end. Anyway, why did you write this book? Why did you get motivated to write this book?
We talked about this for many years before we actually got down and writing it. And we discussed numerous ideas and things and wrote numerous chapters which we rejected on our own part. But then COVID came along, and I felt I needed a project to keep me busy. And so this was my COVID project. And it was very exciting. Janet and I worked on it very hard. And as the centre's told us, it's an exciting subject to actually try and change people's views and to take a different look at things from the point of view of a scientist, not the point of view of a historian. There is a difference, because I asked myself, am I talking rubbish or is this the right thing?
Right. Okay, so I'm gonna go. We started when we came in, but you told me that you have been told by Imre Lakatos here in London, which I found fascinating. So if you don't know, Imre Lakatos was a Hungarian that came to London and worked a lot in the London School of Economics, doing philosophy of science with very good friends of Paul Feyerabend, who question a lot, a bit like you. How is the structure of scientific, if there is progress, whatever progress is. And so in your book, you've examined, and we saw in your presentation, a lot of different examples from all across the sciences, all new. And trying to figure out how you create establishments, you create those rebels that go against the establishment, the creation of the dogma and power. So this intertwined of social hierarchy and so on. So as I said, many people have looked at this before. You mentioned not only historians, philosophers. So in all your study, have you seen something new? What new patterns, what new information have you learned from looking at all your studies that other people
Well,
have
the
not
newest
said?
thing, of course, is AI. I first met Jeff Hinton in Princeton in 1971. And that got me interested in it. And so interested that my wife Janet started a company developing just for that purpose. It was new and a new way of looking at science, and would provide in the long distant future a positive way of seeing the world. Now, this is a great debate and will be the great debate of the future. And we added the last chapter in the book just as an introduction to where it came from. But the story is only just beginning, and I think we'll be debating it 30 years hence.
Well, the story is from the 1950s, but
Yeah.
it's a long story.
Yeah, the long story probably is even earlier, but certainly what we tried to do when writing the book was to make the possibility that we were thinking to have young readers that are started on science, and they will look at science if they read the book with an idea which is much, much broader, in the sense that typically, I see this in our students, they need to be focused on their topics with a strong level of specialization. But this is dangerous because they lose the whole picture. And I think that it's very important also from the very beginning to have a critical view, and the critical view of science can get only if you look at the different topics from with a very broad mind, and do not get things for granted, or you have just to get old ideas or new ideas and try to understand them. And it's a different thing because just following the mainstream.
Yeah, I agree. So on that comment, I have written down in my notes the greatest Spanish philosopher, which is one of the greatest philosophers of technology, Ortega Gasset, who wrote a lot about this, about the barbarism of a specialization that could engulf the human spirit. And so today, with data science, artificial intelligence, I was discussing with them at the beginning that, for example, Larry Ellison, how just moved to Oxford, is making a multi-billionaire investment in a private research organization, the Ellison Institute of Technology, in which he is based, even though he doesn't belong to university, shaping the whole thing we're doing. And basically, he wants to base everything on data and algorithms. If he could shut down physics and mathematics and anything that has to do with thinking, which is rather scary. So I want to ask both of you, since you mentioned AI and you mentioning all this barbarism of specialization. So do you see in this new cult of data a form also of a new intellectual control? So our, like you said, scientists are going to be looking for money, are going to be looking money for the PhDs. The governments are not giving money, and only people like Larry Ellison of the Gates Foundation, which are giving the scholarships, they just want them to do data so they can feed their structures. So
I mean, data is fundamental for science. I mean, you have to deal with that. And we as astronomers love to work in big projects like Euclid or LSST or other kind of projects that compile a lot of information from within the best telescope, the James Webb Telescope, the Hubble Telescope. At the end, all these are data, and the data is fundamental. I mean, it's interesting. The book is explaining, for instance, how Kepler, when Tycho Brahe died, was able to more or less stole the data, because Tycho Brahe was a fantastic observer without the telescope at all, but without the data that Tycho had collected during his time in Denmark and in Prague, it had been impossible for science to evolve, in the sense that Kepler, in terms of Kant, was one of the more clever minds at the moment, was able to formulate the three laws of the movement of the planets. But that was completely based, in particular, of the data that Tycho Brahe provided him. But he not passed the data. The data went to the family of Tycho Brahe, and he has to deal with them. It's an historical fact, but at the end, data is fundamental. The problem is with the data is private, or is just for. I could understand that in science, when people get data, they have to get profit of this data for a while, more or less privately. But in astronomy, fortunately, we have the behavior that this data has to be released to the public in a year, typically. And because the money that has been used to get the data is money that belongs to everybody. And then I finish just with the idea that if at the end the data is used only privately by private companies, or it's even stolen with all these high technologies, because they wanted to know what kind of market. This is a different business, and the thing is, at the end, people in these companies are using developments that were done in science or even in basic science. But this is something that we have to deal with, and I don't find a solution for that.
Very difficult, yeah.
Yes, there are many difficulties, especially nowadays. Things are getting harder and harder for science, with political decisions which work very strongly against it. In the past, science has always been censored by governments. The nuclear science, which emerged from the pre-Second World War years, and right through into the early 50s, was severely censored. We got a glimpse of it because one or two people got leaked information about how nuclear reactions work. And George Gamow was an example of this. He was a Russian who defected to the West. He tried defecting to Finland by rowing a boat across the Baltic Sea. Absolutely crazy. He was caught and saved, I suppose. And he looked at the abundances of the Earth's soil and said, well, how do I make all this stuff? And he actually managed to circumvent and open up this science. Unfortunately, he was a victim of alcoholism. He was very depressed because he had to leave Russia and his culture. And I saw his last seminar in London.
No.
It was very, very sad, from what is a great man who told us.
He has a great book as well.
Yes, that's right.
The 50 years that shook physics, or 30 years that shook physics, which we recommend.
All his books, even Mr. Tompkins'
They are great.
Wonderland,
Wonderful,
are
wonderful.
teaching relativity to students. But there are other strictures as well. publishing, you can only publish your paper if you can afford the page charges now. And some people see a publishing company's plot. I hope people will forgive me when they're in the publishing industry. But
Well, it's even worse.
$40 to read my own paper is a bit strange, I find.
It's even worse now. They're selling the data of our papers for purposes that the research was not intended with, and the conclusions that we'll reach, who knows what conclusions will those be. So we're in an apocalypse of data at the moment.
Well, 2 years ago, the Dutch publishing company Elsevier
Elsevier,
made $45 billion
out of our work.
simply from publishing and charging people to read our work.
Out of our work for free.
Yeah, we have the archive in
Yeah.
physics and science, and so most papers are actually pinned up for free and then published, so those who have no access can read it. And I think that's the most open science is something which I would applaud all the way down. And one thing which encourages open science is international collaboration. It is very difficult also to have a thing like the International Space Station, and for one government among all of them to say, well, we can't afford this, we're going to cancel the whole project. It becomes a political issue. However, politicians have now learned to say, oh, I'm going to tear this contract up, I'm not going to follow it anymore, which raises even more futures for science. Are we going into dark ages?
I think, well, it's very unlikely. I mean, as things are going now, that the European Union even researched collaborative research will survive the next 10 years. It's unlikely. Okay, I'm going to finish with one last question, and then I ask the public to give us some questions. So I just wanted a little bit to discuss your heroes, the heroes of your book. When you say at the beginning you started writing this book and you suddenly found a lot of women, I'm not surprised because one thing you know is that to confront scientific dogmas, you need to the people that confront scientific dogmas usually come from marginal voices, inconvenient people that are looking their freedoms to the truth. You can only be yourself to find your truth, and for that you find your freedom fighting the establishment. So this is a very complicated topic. I myself have a very difficult career of women in science. We're usually quite confrontational. We come out with things that nobody wants to do because it's the way we find our space. And as you discovered, this is very important for science, even if they don't recognize us, because we are a constant force for telling people you're doing this not because it matters, but because it matters to your politics. But my reality will set me free and other people free. So there's this struggle between the rebel and the establishment, which you've discovered with the women. So I work in equality and diversity at my department. I help women which get harassed and all these things. But I worry, and I want to share with you that with our good intentions to make science more inclusive, as usual, as we know in science, you try one thing, but everything is complicated and you get the other in this sort of crazy contingent world. So are we actually maybe creating a perverse system that even makes it more difficult for the real rebels? Where are those rebels? And how it's an impossible problem, because in order to have progress you need a rebel, therefore we cannot have inclusion. So how will we break this conundrum?
It's really complicated, but I would like to come here with some of the ideas that I learned directly from Virginia Trimble. And obviously she was one of the first, for instance, in observing in many places and breaking the sailings in many occasions. But she always tries to explain me that the normality will come when the gender and inclusion commissions are not needed anymore. Yeah, but I mean, the fact that we need them because we have problems of harassment and all these things make these actions absolutely necessary. But this the only thing that this proof is that still we have not reached the equality goal, and this is something in which we have to go step by step, and but probably it's not a single path. I mean, it's more strange way, because sometimes we win something and then sometimes we lose something. But in my opinion, we have to continue with these activities that you are involved in, and you have explained it, but with the goal that at the end, really people do not need it. For instance, the example of Jocelyn Bell, that now she didn't she didn't win the Nobel Prize, but she won all the other prizes, probably even in more
Nobody
economical
knows the other guys, but everybody knows just
Exactly. Well,
she won. That's what I was trying to say. Who actually
win. Yeah, or Martin Ryle. Yeah, that's true. Yeah, and for instance, there are other people in the book. Cecilia Paine, for instance, who was the lady who really discovered the material in which the universe, the stars are made. I mean, she put the hydrogen and helium on the business, and nobody believes her. Even her supervisor didn't believe her thesis, and other people has to say at the same time that that was the best thesis in astronomy published in the 20th century, and with the most important results came there. But it was not a simple life for her. I mean, she was the first professor in Harvard, but it was not a simple life. And obviously things are much better now. And we have now for a royal astronomer. Yeah, but certainly we are very far away of what I was saying at the beginning of normality. And when we reach that point, I hope in the future, things will be much better, and light will be more equally for all people. And then I finish with that. At the end, these rebels will be men or women, has to exist in science always. But for these people to come out, like many of the heroes in our book, we have to create the environment and to allow again the broad view of science, and not to constrain to the very specialized extreme lines that are powerful in the moment.
Thank you. That's leaving me with this will say heroines. I'm going to talk about my heroine in the book. Is the Duchess of Newcastle.
Right.
At the time of the Civil War, we have quite a lot about these women in the book. It's quite interesting. The woman who was to become the Duchess of Newcastle, basically was a victim of the Civil War. Her husband and her were in a bad situation. They were rich. He was a duke eventually. But they had to leave Britain because otherwise their lives were threatened and everything. She was crazy in the sense that Samuel Pepys, the great British diarist, called her Mad Madge. So crazy that when she wanted to keep her husband's life sane and balanced. So when she went to Paris, the first thing she did was they had a huge house given to them because they were important people. But she started a salon. This was the equivalent of the internet today. She had as guests coming, and she sat among them. She didn't serve the coffee or anything like this. She was among them and discussed science and wrote about science. It was mad, but she wrote about it. And she had Descartes and Mersenne, the mathematician, and other people come to her salons. So only 2 years later, or 1 year later, was in fact, there was a revolution in France at that time. So they were driven off to Holland, where she repeated her feat. Eventually, they got back home, and the restabilization of Britain was to go back to the same thing. And the Duke got back his property. He didn't get back his money, but she calculated how much money they had lost because of the war. But she's a real heroine, I think. There's lots of totally.
And the name, Margaret Cavendish.
Margaret Cavendish. Oh, of course. Yes, she's a member of the Cavendish family. I forgot. I keep on forgetting her, but Cambridge is dominated by the
The
Cavendish.
Cavendish.
Apparently,
Okay.
even got a new one.
They do.
Yeah.
An enormous undertaking. Okay. So, any questions from the audience? Yeah. Nothing.
Thank you very much for such a nice talk, and I hope really looking forward to read the book. Well, if one is trying to slay the dragons of Dogma, one should be able to do at least two things that are very difficult in scientific publication today: to publish negative results and to publish data without a theory. And theory, I don't know in astronomy, but in other fields of physics are very, very difficult. If you just publish data, yeah, I don't understand exactly this, but this looks interesting because it doesn't fit. It has become really, really hard, and I just wanted to know about
A bit of this one.
what you can say about it.
I mean, for example, when people have data, when scientists have data, I should say, they collect it not with a view to just building the data. There may be things that we don't know, but there are things that we want to refine. So in a sense, the great discoveries come as byproducts of an earlier process. So, for example, the Webb Space Telescope has taken more data, I think, than anything else on the planet. Maybe the little Higgs boson has actually cost a lot more per fact than anything else. Physics is quite well endowed at the good times. But I agree entirely with your sentiment of that you express about publishing non-results. When I was a student doing my PhD, I tried to solve a particular problem, which was later solved by Bardeen II, the brother of the guy who won 2 Nobel Prizes. And I couldn't do it. It was impossible to solve the whole problem. And then I talked to one of my friends, Joseph Silk, in fact, and he said, I tried that and that ages ago, but I couldn't publish it because there was no answer. And I said, oh, that's interesting. And then when we were both in Paris together at one point, we were talking to somebody else. Says, oh, you tried it too. We've all been wasting our time. Well, you don't waste your time by fiddling around with things. You explore and you learn, but you would love to have a publication because nowadays your success is counted in your ability to publish or perish. Einstein would fear very badly. No one on earth would employ Einstein because he has 0 citations for relativity.
Of course, big things don't need science.
Huge things. I mean,
Well, I have to talk about I'll give you a moment about the publisher, and it goes to your question. I mean, World Scientific did a nice work, and the first thing he did was to propose an editor who is here, Keith Mansfield. At that time, was working for World Scientific, and he did a complete revision. Probably he was also in the COVID time. He has a lot of time, and we got a report of 30 or 40 pages. I mean, we have to redone completely the book. And one of the things he proposed was to start the book with a plot. I remember quite well the word, with a plot of the Michelson-Morley experiment. And this is how the book starts, exactly with that. It's a plot starting in 1887, July 1887, explains where, the basement where the experiment is going to be done. But this goes to your question. It was an experiment that proves that ether really do not exist. Ether is probably the entity that has been postulated and for centuries, from the time of Aristotle to now, and to the beginning of the 20th century. And the experiment is done in 1987, and nobody believes in it. 1880, sorry, yes. And nobody believes on the result, and because it's a negative result. And many important scientists wanted that Michelson and Morley found that the ether was there just to explain that the electromagnetic radiation has a media to be transported, like my voice now is transported by the air in the room. Without the air, you don't have this media, and you will not hear me. But they thought that for the light was the same. They need this ether, but the Michelson-Morley experiment, which is a modern interferometer, shows that it was not that. And when they explain this really nobody take care. Finally, Michelson in 1907 got the Nobel Prize. And after getting the Nobel Prize, and also because Einstein used the special relativity in 1905, and in that case, either it was not needed because the constancy of the velocity of the light, independent of the framework, then this starts to be considered. But the experiment itself was really not appreciated, and every people know it, but awareness is not the same that appreciation. And the Nobel Prize was not given for that. Was given for a measurement of the matter using, again, interferometry. But, it probably is the most important experiment, but it was a failed experiment. I mean, the result was negative. And certainly this is quite good, because science needs this kind of experiments as well.
Just I think we don't have next. Oh yes, hello. Then you was okay. So just the book is the target audience for the book is not scientists. I mean I didn't finish the book, but I started to read it at least for the general public, people interested in history of science. So that's just recommend your book to the general public. I guess somebody could be scared about it. So as a final, maybe.
Yeah. Thank you, Victor. It's a good idea. I mean, it's really. I have several books on popular science in Spanish and Catalan, and this was probably the level here is higher, because two reasons. I mean, the main one is that the book cannot be a bestseller, and Keith told me, because we are three authors, and the books that are bestsellers has to be single authors. Okay, probably your books could be a bestseller. This is this is something that it's a theorem, and then we have to accept it. But we were also saying that this book couldn't be written by any single author of us. Probably Virginia could be, but at the end, each one. I mean, everyone has interacted in all the chapters. Well, I think at the end is something coherent and looks for a broad audience. Because the language is simple. There is a sense of humor, American, British, and Spanish all together, and this is a nice mix. And you can follow the difference with a normal popular science book is the footnotes. Okay. But you don't need to read them. You have them, but they are 45 pages of footnotes. Okay. And this is something that we decided, because if we include the footnotes even in the same page, they went at the end, because then you forget it if you don't want it. You go if you like to read. But this is the only difference. We try to move any kind of, and also Kate helped us a lot on this, that was quite hard for a general audience to a footnote. That means that you get the freedom for the reader to read it or not. This is right.
Yes, I think we owed a great deal to Keith's putting up with our writing. And immediately I took a couple of chapters and wrote them and sent them to him. He said, "That's better." And I thought, he's a good critic. That's but criticism in science is extremely important. One should be able to publish without trying to diminish the work of other people. And this is what's happened, for example, in the dinosaur debate. You can't publish a paper which says that dinosaurs were killed by something else other than that, because if you go to a meeting, you'll get slagged off by everybody and anybody because everybody believes it's a meteorite. It's going to be a very difficult move to make. Gertrude Keller's now retired, but she has a whole band of students out there working on her behalf. And I think that in the long run, we'll see. There are two views. Great thing to join. And I think that the human aspect of science, I hope, comes through in the book. It's about the people. Why Newton hated Hooke. Why did he cancel Robert Hooke? These are things you don't normally see in these books. And I think, to me, science is people. I love being a scientist because I get the privilege of traveling around, even meeting people who are not cosmologists. That's even more interesting. And,
We are very rational.
yeah, of course. Yeah. Yes. So,
For one question.
Yeah, thank you. Thank you very much for your words and for the book. I think I will read this. This is geopolitics. I'm a humanist. I'm not a scientist. How do you see the world now? Do you think that science can thrive in an open society? How do you see China and the United States and the European Union, UK now not in the European Union? How do you see that? You think the question is, you need an open society for science to thrive, to develop?
that's a good question. I think I find it a bit of a depressing question, if I may say. I think that science in those circumstances doesn't thrive because it doesn't have the funding to do the research to develop. But then the whole of society suffers because take, for example, electricity. Electricity was talked about by Faraday in the early 19th century. James Clerk Maxwell explained everything by 1850, 1860, and it wasn't exploited till 1906. It took 100 years. It wasn't any real opposition. It was an unwillingness to go for it. If Mr. Hertz hadn't manned his experiments while his wife was giving birth, we would not have radio. I think somebody else would have done it. But he writes in his diary that must disappear now. The observations are very exciting, but my wife's having a baby. He got there in the morning after the baby was born. Science works because we want to advance and have better lives, and science in general provides better lives for us. Yes, we have nuclear weapons. Yes, we have intelligent drones which will go around killing some people but not others. The whole thing is very chaotic. So we've survived so far, and I'm a great optimist. I'm the world's greatest optimist. The world will survive it. I mean, hopefully the next generation will be a lot happier in terms of science.
Yeah, I agree completely with Bernard. The only thing that I would like to add is that we both have been loving the international collaborations, and we were talking about Russia this morning and Ukrainian. We have colleagues in all the world around our history, and this starts to be difficult now, and this is a problem. And this really goes against the good way of science. I mean, we would like to have the freedom to continue collaborating with people in Russia, with people in China, with people, and it's not easy. It's not easy because the world has been. It's now crazy and politically and borders and the wars, and this has happened already because after the First World War, the second again, but now we are in a moment. It's not a cold war, but probably it's a warm war. I would say, and we have to pass this if we want to continue with this international aspect that for science is absolutely necessary.
During the Cold War, we still collaborate with the Russians more than now.
Yeah, exactly. Exactly.
Not even.
Yeah, exactly. Yeah, with Eldovich and all these people. Yeah.
Okay, so I think we need to finish. Everybody's in this time.